Thank you for coming here. Migrating onto Google Cloud Platform is a journey. And with any great journey, it starts with a single step. Now, if you're sitting here planning to think about that first step, or if you're running a marathon on the GCP world, I hope Unity's experience over here would give you some of the insights on what's to come. Although I will touch upon the overall migration of Unity onto GCP, but the focus of our talk today is on the networking piece of the whole migration. But before I jump in, I do want to take this opportunity to introduce ourselves. Ariel, who is the lead networking architect at Unity. She's been closely involved not just with the migration of networking onto GCP, but also running the workloads on GCP ever since we migrated. Her perspective as a customer of GCP is very valuable because she brings a very different perspective, which is your perspective to the whole story. Thank you, Ariel, for being here and sharing your stories with us. It takes two hands to clap. I have Davis here, who is our networking engineer from Google. He's been the backbone of the migration from a Google side. And today, he's going to bring the Google's point of view to the whole migration and probably share some inside scoops on the migration. I am Ananth. I'm the technical account manager for Unity from Google. Along with my team of engineers and consultants, I'm responsible to make sure that Unity is successful on GCP. In short, the voice of Google in Unity and the voice of Unity at Google. If you have any questions during this session, we're using Dory Q&A. Please do go on to your next app, click on this session. You will find a link for Dory Q&A. Please do write your questions in there, and you can upload questions that you think you want to be answered over here. If you're not able to answer any questions, we'll definitely get back on the Dory Q&A with the answers. All right, before we dive into any of the details over here, for those of you who don't know what or who Unity Technologies is, Unity is a big name in the gaming industry. It's among other things that Unity is known for. It's known for its Unity gaming engine, which is a platform that helps game developers build games. Assassin's Creed, Pokemon Go, are some of the many games that have been built on Unity itself. They've had more than 29 billion installs, 29 billion installs of Unity experience in the last year. If you think about it, it's about 3.5 times the population of the world. They are a key player in the AR, VR, and the mobile games industry. At Google, our vision is to create, connect, and scale games. We've had the greatest of our Google products invested in this vision, and together we're trying to make sure the gaming part at Google is successful. With the addition of Stadia into our arsenal, I'm very excited to see how the space turns in the future. Now, what happens when you bring two big names together? Magic. Along with Google and Unity have been partnering on multiple fronts to make gaming experience more rich and more inclusive for everyone. We have a bunch of sessions during Next that talk about various initiatives that have come out of this, such as connected games, matchmaker. I would highly encourage you to attend those sessions. But before all this magic actually happens, Unity had to get onto the Google Cloud Platform. And that's where the journey actually started. With the scale of Unity, we had to do this quick, and we had to get this right. Unity had offices across the globe, and we had to make sure that each of these offices, the workloads running out of them, had to be migrated onto Google Cloud Platform. My team was entrusted with the task to make sure that this migration is successful. The PSO org, the Professional Service Organization, is a team of technical account managers, engineers, and consultants that work on ensuring that customers, such as Unity, can accelerate as soon as possible on the Google Cloud Platform. We are spread globally and quite effectively that way. Long story short, in a span of 6 months, we were able to successfully migrate Unity onto the Google Cloud Platform. Now, we're not going to get into the nitty-gritties of the migration. If you are interested, again, there's another session tomorrow that talks about this in quite detail. There you go. So here we are. After the migration, Unity has been using a whole host of Google Cloud products, right from compute all the way to cloud AI. But the focus of today's talk, we're going to deep dive into the networking components that we have. Along with Davis and Ariel, we're going to talk about some of the experiences, challenges, decisions, and hacks, both on the Unity and the Google side that we made on making sure all these products were onboarded and are successfully running at the moment. We're going to take a quick peek into the networking world of Unity. We're going to share our experiences on the migration phase itself and the processes that were put in place for post-migration to ensure that Unity's networking workloads are set up for success on GCP. Ariel, once again, thanks for sharing your experiences on this.
Of course, and my pleasure. And I hope sharing our experiences here can be helpful to the audience here. All right, thanks. So before we dive into the network architecture of our Unity in GCP, I want to run through some characteristics and requirements of our infrastructure. So we have a hybrid infrastructure. So we have some small footprint in data center physical location, and most of our workload running in public cloud. And our infrastructure is not only span across multiple regions, it's also span across multiple clouds. For our backbone, it's primarily IPsec-based, but for some workload, between certain environments, we do have the requirement to have much higher capacity bandwidth requirement, where multiple of IPsec tunnels are not going to meet the requirement. And also, our infrastructure have a very high growth rate, so our design in GCP need to be able to scale. So with that in mind, when we start our journey in GCP, started build in 2018, we work with the Google team and quickly come up with a set of key architecture decisions. Those decisions then later on play the key factor into determine the final GCP network build. So first, we work with the Google team. We decided to use one VPC for transitive routing between GCP and the other cloud infrastructure we have. And also, we know that, especially during the migration, we will need some partner interconnect-based product to link between certain environments to provide much higher bandwidth. And also, we decided to use global routing versus regional routing. The reason being is because with the global routing, we will be able to do failover between regions, hence increase our network availability. Also, we decided to use cloud routers. So our team do have experience to use over-the-shelf virtual routing and encryption equipment. And also, we have the experience of manage and maintain Linux-based open source routing and encryption processes. However, we choose to use Cloud Router because it's purely API-driven, and it makes our automation super easy. And also, we decided to put some workload into shared VPC architecture. The reason to use shared VPC architecture is because use the architecture, it allows us to aggregate all our workload into a fewer VPC, hence reduce the ongoing operational cost. So equipped with those key decisions, we dived into the POC pretty quickly. And there are many lessons learned, and there's something specifically related with routing I want to share with the audience here. So the first snag we hit when we try to do transit VPC is the interoperability between CSRs in AWS and the cloud routers in GCP. So the CSRs in AWS are behind the NAT IP address. So by default, when it's trying to negotiate do the IKE negotiation, it will use the VM's private IP as the local identity. And that caused the router, the VPN in Google side to reject IKE negotiation. So the fix is fairly simple. The fix is to have one line of command in Cisco CSR under IKE, where you can specify to use the public NAT IP of the Cisco CSR as the local identity for IKE negotiation. So with that, we continue to look into the routing aspect of the transit VPC. For routing, we use Cloud Router. Cloud Router, for me, is like the VGW in AWS world, in the sense that it provides functionality to allow dynamic routing exchange using BGP, as well as it have the ability to propagate the route, to program the route into the VPC or subnet. However, there is one key behavior difference there. So for Cloud Router, they don't really automatically redistribute the best route, the BGP route, between the BGP peers. And also, we noticed that as we learn more about GCP, we realized we need to do route summarization. Reason being is there are certain limits you need to be aware of. There is a limit about how many prefixes you can announce through a BGP peer, and there is a limit on how many prefixes, unique prefixes, you can program into a VPC in GCP. So to do route summarization, we choose to use customer routes. And you can do customer routes on the per Cloud Router level or per VPN level, the BGP peer level. And also, while we start to experiment and doing POC about this transit VPC idea, we learned that there is a need for two sets of cloud routers in each region for transitive routing. To give more color on that, so this is a simplified diagram on our initial POC, where we will have one cloud routers in the middle portion, which is a transit VPC. That is, cloud router have a BGP relationship with the CSRs in AWS, and also it have BGP relationship with the environment 1 VPC, which we call like downstream VPC. And that cloud router in transitive VPC will learn a prefix 1 from AWS, from the CSR, and we use customer routes and hope that the customer routes will then be re-advertised into environment 1 VPC, but that's not the case. So in the end, we have to use two cloud routers. So in the transit VPC, we have Cloud Router 1 and Cloud Router 2. Cloud Router 1 is used to receive the prefix from the CSR, and then the cloud router will then program the route, the route into the transit VPC routing table. And Cloud Router 2, on Cloud Router 2, we will then use customer route to announce the prefix 1 into the environment 1 VPC cloud router. By doing routing this way, we will be able to do transit routing between AWS and the environment 1 VPC. So now, here is the diagram shows our routing with more detail. So the middle section is the transit VPC. And in the transit VPC, we have cloud routers in different regions. In each region, we have a set of cloud routers for 1+1 redundancy for connectivity and exchange routes with the CSRs in AWS. And also, we have a set of transit cloud routers for route exchange with the environment with VPC cloud routers there. And also within the transit VPC, we use global routing. With global routing enabled, each of the global route, the cloud router will have a global route view of the whole VPC. What it means that if, for example, we have the BGP or BGP fail within region 1, and the workload in the environment 1 VPC will still be able to reroute it through the nearest region to reach AWS. And also here, you will see the bow tie style of connectivity. I want to stress that it only represents the control path for routing selection. So for actual data paths, it goes through the VPN gateway. So for VPN gateway, we can scale horizontally as we need. Sorry. And now let's look into how we do networking inside the environment VPC. So we use shared VPC. In this diagram on the top, you will see a shared VPC in a host project. In that shared VPC, you will see that we have cloud routers in many different regions. And then from that cloud router, we have connectivity to the upstream transit VPC. And also in the shared VPC, we create a subnet in different regions. And then we share the permission to use the subnet with the maintainer of different resources in the service projects. So for our development team, they know if they get a subnet from us, from the shared VPC, if access control permits, they will be able to reach to the other workload, regardless of which region that workload is in and which infrastructure that workload is in. So this is how we do networking in Unity in GCP. But there are many other options that you can use to connect different VPCs and infrastructure together. So next, Davis, do you want to go through those options?
Absolutely. Thanks, Ariel, for walking us through Unity's network architecture, as well as highlighting a few of the caveats you mentioned. Now, at this point, I want us to take a step back, because I want to highlight what are the different design options for interconnecting VPCs in Google Cloud. So Unity leveraged VPNs, but based on a use case, you could leverage different design options. So and for each option, I'm going to highlight the advantages and the constraints, and hopefully this should help you make the right decision as to how to interconnect your VPCs. So when you leverage VPNs, the major advantages that it gives is it enables transitive topologies if you're using static route-based VPNs. And if you need dynamic route-based VPNs, you have to use 2 cloud routers, as mentioned earlier by Ariel. Secondly, you can scale the number of VPN tunnels if you need higher bandwidth. And also, the choice of the tunnel is based on a 5-tuple hash. It is a managed service and has an SLA of 3 nines. Now, what are the constraints with VPNs? Each VPN tunnel has about 1.5 gigs over public internet. So you can, of course, scale with adding more tunnels. And also, you need to account for the IPsec headers, right? So on the remote end, on your on-prem router, maybe, you have to configure 1460 bytes for your Ethernet MTU. This results in a decrease in the maximum segment size and hence lesser goodbit, something to be aware of. And finally, I'm sure at least few of you in the audience, if you have ever created an IPsec tunnel, would have troubleshooted IKE phase 1, phase 2 negotiation. So there is a little bit of overhead and management issue, constraints. So the next approach for interconnecting VPCs is by leveraging a multi-NIC VM, where each network interface goes to a distinct VPC in the project. So this is a typical, as illustrated in this diagram. So this is a design option that you would leverage when you need all your traffic to go through an appliance, like a next-generation firewall that does deep packet inspection. Now, with this approach, what are the major advantages, right? So each core or vCPU of the VM has a peak performance of 2 gigs. And if you leverage 8 cores, you get 16 gigs. But adding more than 8 won't give you higher throughput. So, but this is, again, soon to change. You can also scale through managed instance group and ECMP routes. The major constraints involve that each VM can have a maximum of 8 NICs, meaning you can interconnect maximum 8 VPCs. All these VPCs must belong in the same project. And today, load balancing is only supported on NIC 0. And for non-NIC 0, you would have to leverage GCP static routes and ECMP across them. That is by having multiple static routes with equal priority. The final approach for interconnecting VPCs is by leveraging VPC-Peering, where you peer to VPCs using Google's SDN plane. So these VPCs can be in different projects in the same organization, or it could be across different organizations. So here is VPC-A peering with VPC-B in the diagram. So the major advantages is it's very high bandwidth, right? It's as if all the VPCs in the peering group is a single VPC. It's very easy configuration. All you need to state is the project ID as well as a remote VPC you want to peer with, and that's pretty much it. And you have granular control as to the custom routes, the dynamic and static routes you want to import and export. And what are the major considerations? So it is non-transitive. So if VPC-A peers with B and C cannot communicate with each other. They have to be directly connected. Also, something to be aware of when you operate at very large scale is that certain resource quotas are aggregated across all the VPCs in the peering group. Just to name a few is the VM count and the internal forwarding rules. So I hope highlighting the advantages and considerations will help you make better decision choices with your network design in GCP. Now, coming back to Unity's network journey, right? Certain key efforts were taken by the teams to onboard internal customers into a completely new platform. Also, tooling was developed by the infra team at Unity in order to easily enable customers to use a shared VPC. And I'll have Ariel to speak more on this.
Okay. All right. So after we built the network, we spent a lot of effort to onboard our internal customers. And it's a big effort, and it's effort actually across many different teams, not just us. So first, we run a lot of onboarding-related presentations. We have the presentation with different customers in different regions. And in the presentation, we focus on describe to the customer what's the new architecture in GCP, what's the characteristics of our network, such as what's the bandwidth supported, what they can expect in terms of bandwidth between different environments, what's the latency, and what's the service level objectives that we use to come up with the network design. And those informations are very important for our development teams to be able to eventually come up with their migration strategy that can be supported by the underlying infrastructure. We also created a GCP Kickstart guide. It's a guide that provided step-by-step instructions on how to start in GCP, such as how to create a project, how to access to the project, how to be able to share the permissions with the other team members. And we also created a portal for project creation. It's not as simple as just create a project. It's actually a suite of actions. It will create a project, and if the project requires access to use the shared VPC, it will then be attached to our host project. And also, it will delete things like the default network and create relevant service accounts. And we also create a portal for firewall rule request. It's a GUI-driven portal, and turns out we didn't have the very high adoption rate as we hoped because most of our developers like to write infrastructure in code, although it proved to be very useful to some teams and some people. And then we decided to share our Terraform repos on subnets and firewall rules with the development team. And to do that, we use Terraform modules whenever that makes sense to enforce certain standards and templates. And also, we find it's really useful to install some linters. The linters we installed in our Terraform CD pipeline, it allows us to be able to verify and qualify a merge request before a human come to review the merge request. What it does is, for example, it will check if the format is right, if there is any syntax errors, or if there are any variables used that are not declared. Also, it will check that, for example, for firewall rules, it will check if the firewall rule name is more than 63 characters, which typically you will only notice that at the time of the Terraform apply, and it will be able to expose to you because Google API will give you an error. But with our linter, we can detect those errors upfront. And using these methods and tactics, that it helps us to onboard our customers, span across different geolocations without us being the bottleneck. As we onboard customer, we also start to work on the network monitoring and logging because we want to make sure we have the visibility of our network health within GCP as customers start to, our internal customers start to iterate within GCP. So we have our own in-house monitoring implementation. With the help from our monitoring and logging team, we quickly implemented some backbone connectivity monitoring. It will monitor the connectivity on the latency and availability between different environments within GCP and outside GCP. We also use our in-house monitoring for metric gathering of some VMs running network services, such as network address translation. And we also heavily utilize Stackdriver logging and monitoring, especially for elements such as the Google VPN gateway or Google Cloud routers. So speaking of Stackdriver, Davis, do you want to give us some examples on how to mine the Cloud router events using Stackdriver logging?
Absolutely. Yeah. Thanks, Ariel. So I'm going to walk through a few examples of using Stackdriver logging queries to determine Cloud router events. Right? So the first one is when a cloud router is being upgraded or migrated. So this is usually when, since cloud router is a fully managed service, right? It does undergo upgrades and patches, right? And these upgrades are completed in less than 60 seconds. The hold down timer is 60 seconds, meaning traffic forwarding and should not be affected, and as the routes are preserved. So what you need to look out for is, not sure if it's clear. So essentially, you go to Cloud Console, and then you hit logging, Stackdriver logging, logs, and you convert into an advanced filter where you search for resource type GCE router and look for the keyword task activated. So this is something that you should track. This is an event that you should track. Next is something, an event when a BGP-Peering goes down, right? So this is essentially a network outage if you don't have redundancy in place. So a critical event to look out for. What happens is you just need to look for the keywords BGP-Peering and went down. And as you can see here, 1.6, the neighbor 1.6 has gone down at that particular timestamp. And immediately after the neighbor goes down, well, the routes are going to be evicted from the VPC table. And what you look for in this case is the route event and deleted from the cloud router. So as you can see here, 10.2.0.0/24 is being evicted from the same router whose peering session went down earlier from the earlier slide. So this is essentially, I just wanted to give you a glimpse of how you could use Stackdriver logging queries. Now, what do you do with these, right? So you could export it into PubSub and a PubSub topic. And you, as these events occur, you could trigger a cloud function that executes an API for remediation. So that is kind of the capability of Stackdriver. And well, I now want to kind of focus on a particular network service, which is network address translation. The reason I bring this up is because there are a few considerations with its implementation, and I believe it will be useful to you to be aware of it. So firstly, there are two approaches, right, to implementing NAT in GCP. The first one is self-managed NAT, where you run a VM with NAT software, or maybe a Linux VM doing IP tables for NAT functionality. So what are the considerations with this approach? You need to monitor the VM for scale as well as for load. You need to create certain scripts to do this. Second, I cannot stress enough on this, it breaks Google private access. So now what is private access? It's basically private VMs having the capability to make GCP API calls and services through Google's backbone. This is made possible using a default route with the next hop as default internet gateway. So when you override that route and you state when you create a default route with next hop as NAT instance, all your traffic is going to go through a NAT instance. And it overloads the NAT, and it might bring down the NAT instance. So I've been on many troubleshooting calls, essentially fixing this. So I think you should, it's an important caveat to note. Next is the same point I mentioned earlier with multi-NIC VMs. It's each vCPU has about 2 gigs peak performance, and as you use 8 cores, you get 16 gigs as max for peak performance. Now, what is Cloud NAT and how does this help at all? Well, it is Google managed service. It has an SLA of 3 nines. It is highly available as well as auto scales without any user intervention or management, right? The perks of running a managed service. Now, private Google access automatically works, and your bandwidth is as if your VMs that need to be, your private VMs that need to be NATed, having an external IP. So essentially, huge performance benefits. Considerations, though. Cloud NAT does not support application-level gateways. What this means is certain protocols like SIP and FTP, they require the IP in the application PDU to be NATed also. So Cloud NAT does not have that functionality today. Logging is an alpha. And also, finally, I want to make, so when you create Cloud NAT, you have to specify the maximum number of ports which are available to each VM. So if you say 64 ports, by default it's 64 ports. So if you say 64 ports are available to each VM for NATing purposes, and the VM essentially makes a large number of connections to the same destination IP and port, which is over 64, then the packets are going to be packet is not going to be NATed. So you need to kind of plan what subnets or what work streams need to be what work streams need to be made available for Cloud NAT. And I think Ariel will share an experience on its implementation at Unity.
So for our Unity NAT implementation, when we first started back in early 2018, our choice is very simple because there is no Cloud NAT available. So we created many NAT clusters. We have one NAT cluster in each region and each environment. And also we use route tags to route tags and then provide those tags to our development team. So the development team can use these tags. Once it's applied to a VM, it will route the internet traffic. When I say internet, the traffic goes to prefix of 000/0 will be routed through the relevant NAT cluster. So it works well at the very beginning. However, later in the migration, we start to notice that occasionally our NAT clusters may get overwhelmed. And this is a usage graph, and it shows, you can see that the traffic pattern can be really spiky. And there are times when we can have, and this is only a throughput for one environment and one region we have. And at times, we will see traffic goes from 4-point-something gigabit per second to 40+ gigabit per second within 5 minutes. And when we look deeper, we notice majority of this traffic are actually not the traffic go to the public internet. A lot of the traffic is actually goes to the Google API services like GCS or GCR. And then, luckily at the time when we start to experience this issue, Cloud NAT is already went GA. But before we immediately jump into the Cloud NAT implementation, we looked at several different options. We looked at option where we can possibly inject more specific routes in the routing table for certain Google APIs to route those traffic through the Google Internet Gateway that allows private Google access. We also looked at these restricted Google API access feature, but we have some concerns about how to do the DNS in using that feature. And eventually, after some analysis, we decided Google Cloud NAT is the direction we should go. Oh. So when we start to look into migrate workloads into Cloud NAT, the first question we ask ourselves, what are the workloads we should be focusing on in migrating to Cloud NAT? At the time, our NAT clusters occasionally get overwhelmed. We want to be able to stabilize our service. So in order to find the top talker, what we did is to utilize the flow logs. So we enable flow logs for the subnet where our NAT devices uses. And then we send those flow logs into BigQuery. And with a fairly simple query, we will be able to find the top talkers. So identify the top talkers allows us to figure out which development team we then should collaborate with to migrate those traffic into Cloud NAT. And then the second question we ask ourselves is how to qualify if a workload is a good candidate for Cloud NAT. Because of the caveats that Davis mentioned before, when you create a Cloud NAT, you do have to actually put a number for a maximum concurrent connection a VM can establish to a destination IP and a port combination. So what we don't want is to migrate something, jump into Cloud NAT, migrate to Cloud NAT, and potentially have workload experience silent failures that because of the port exhaustion. So what we did is to first, we look into, basically mine the flow logs we have in BigQuery. But for some reason, we find that we can't really find all the flows that for one particular stream before it goes into the NAT, after it come out of NAT, get netted, and come back, and eventually back to the VM. And maybe that's because of the sampling. We didn't look further, but we quickly developed another method. So our team members start to take snapshot of all the connection tracking tables across all the NAT devices within one cluster. And then we have a little simple Go client. That Go client basically injects all these connection tracking table information and pass it, and then stream it into BigQuery. With this method, we basically gain the real-time visibility into the characteristics of all our traffic that outbound to the internet. And this allows us to be able to tell, by looking into a subnet, normally correlates to one workload, it will tell us how many concurrent connections, the maximum concurrent connections from the time we enable the method that can be ever recorded, if that can be supported by Cloud NAT. So after we find the top talkers and qualify if they're a good candidate to Cloud NAT, then we ask ourselves the third question. How to migrate from using our NAT devices into Cloud NAT with the minimum service impact? So we choose to enable Cloud NAT on a per subnet basis. And also, once we enable the Cloud NAT for that particular subnet, then it's up to our development team to remove the NAT tag at their pace whenever they're ready to migrate into Cloud NAT. Once they remove the NAT tag, what's the impact to the existing traffic? For the existing connections, when you switch from NAT to the Cloud NAT, it will send a reset. So for the type of workload we have, the traffic we have, it's nearly like not detectable for this transition. So so it turns out that to migrate to Cloud NAT is actually fairly manageable. But we're still trying to figure out how can we do capacity planning and ongoing capacity planning so that we can take a more proactive position. And that is true not only for NAT, but also that's true for all the other services we manage in GCP. So now, after 1 year in GCP, what should we do? What should we be focusing on? Of course, we pop a bottle of champagne first. And then after that, we know that we need to monitor quota and resource usage. The reason being is that once we situated into GCP, the workload continues to grow. So we have to keep our eye and have a good visibility into all the quota usage and resource usage so that we can be more proactive. And also, we need to focus on optimizing our workload, not only just for cost optimization, but also for service performance optimization. And we start to have more and more ask from different development teams where they have their own self-managed infrastructure, where they want to be able to connect into GCP directly. And for example, now we're working on a project where we will utilize the new Hong Kong region offered by GCP for connectivity and better connectivity into our infrastructure in mainland China. And also, we invest very heavily on automation. We invest on automation for the purpose to have a self-service approach for our developers so that they can iterate really fast rather than create a request and wait for us to do the request. And also for the purpose of reduce operational cost. And also speak from the experience, I think public cloud technology evolved very fast, and also Google released new features on a regular basis. So it's always something that we need to keep informed on the new features and new product and reevaluate our architecture to ensure that we can meet the future growth needs. So this is our network team's focus after the migration. And Davis, you interact with many other customers. Do you want anything else to add anything else here?
Yes, absolutely. Thanks, Ariel. So as Ariel mentioned earlier, right, carefully monitor your quotas. So these quotas are present to prevent abuse of a platform as well as to protect you from unforeseen usages, right? So there are two kinds of quotas. Rate quotas, which get reset maybe every day, maybe every minute, depending on the API you're calling. There's also the resource quotas, which is essentially like your VM count per project, which doesn't get reset. So you need to carefully monitor and proactively request for quota increases because depending on your resource, it does take time for approval. Second, so we are at Next, there are a lot of product announcements happening this week. Do test it out and provide feedback so that we can quickly iterate over it. Also, you have, for the existing products today, there is a platform for you, a platform in which you can essentially file issues and feature requests so that if you feel certain products should behave differently or does not have a supported functionality, well, you can use this. So this is kind of how it looks like. It's a public page, and you just need to determine the component. And if there's already an issue that you want to file, and if it already exists, upvote it so that more eyes are looking at it. Finally, for your favorite GCP products, bookmark it. Example is, well, here's Cloud NAT maturing from beta to GA in November 30th last year. And finally, if you have, we continuously strive to expand our regions globally, right? And well, as Ariel mentioned, we do have a region in Hong Kong, which is Asia East 2. So if you have queries on accessibility of users to GCP resources, like accessibility of users in China to GCP resources, well, there are interconnectivity options. We have the China specialist team sitting in this room right here, or you can come talk to me later about it too.
All right, thanks, Davis. So I hope this experience sharing that we had between Google and Unity has helped you out to think beyond the obvious. And we do hope that while you are planning your migration, you do keep these points in mind. If you're already in would be, you could probably reevaluate it and see if that's the right thing to do, or there are any other things that you can add to what the current architecture that you have. If you do need some help in getting your pipes in order, please give us a shout out. We'll be more than happy to let you know our experiences, or we can definitely connect you to teams who can help you out.